The following presentation was recorded at the third NDS Public Conference in June 2021. My name is Hubertus, and I'm a product manager here for automated driving content. Sustainability is a word that's often used these days, most often in the context of keeping a balance between environmental, economic, and social domains. And you may wonder, what does map data, automotive software, and specifically NDS have to do with that? And I admit that sustainability is a buzzword, and in my defense, I didn't come up with the title for the presentation myself, but nevertheless, when I was asked to talk about it at the conference today, I was intrigued. And I'm sure you will agree with me. We all have the responsibility in our personal and business lives to understand the impact of what we're doing. So let's look at why an industry data standard like NDS should embrace sustainability. Integral elements of sustainability are research and innovation activities, using science to develop innovative technologies. The question is, how can a technology and data standard like NDS help use less resources, achieve a greater reuse, and scale better for a sustainable future? It didn't take me long to make a connection to the problems that we all work on. We aim to make automobility more comfortable, safer, and less wasteful, reducing the carbon footprint of driving. Navigation is proven to help shorten the distances driven by avoiding unnecessary detours and by optimizing routes taking live traffic into account. Driver assistance systems support drivers with safety and comfort aspects, knowing the legal speed limit at all times, staying in the lane, guiding headlights to see better ahead. And driver assistance systems also support ecological aspects. They can select the right gear to save fuel. They can enable advanced cruise control systems, power eco-drive modes, and provide input for hybrid vehicles on where to drive electric. And when automated driving is seeing great adoption, then I'm sure we will see a wave of change in mobility and its ecological impact. Let's look at the current situation to understand where we are coming from. Map data in NDS and software using NDS maps are key to navigation, intelligent speed assistance, advanced driver assistance systems, and automated driving. Teams at system vendors and teams at OEMs approach us at here with these individual problem domains, looking for an individual solution. And at here, we developed individual solutions using NDS for many years. And we productized NDS-based solutions. We have a standardized product offering portfolio for a range of use cases. We have the here ISA map to support the need for intelligent speed assistance solutions in reasonably priced vehicles that are not equipped with ADAS or navigation. We have the here ADAS map, which is a comprehensive here map content bundle for ADAS and electronic horizon solutions. It includes ADAS features like curvature. It comes with routing data that includes speed limits, warning signs, and more. Third out of four is the here navigation map, and it covers the needs of premium IVI navigation use cases. We include and do a seamless integration of all navigation relevant basic and premium here content bundles, market ready and compiled in NDS, so it can go straight into cars. And last but not least is the here HD live map. It caters to the needs of automated driving when the vehicle needs to understand its precise positioning, needs to plan beyond sensor visibility, needs to have contextual awareness and knowledge of the road rules. And with its 3 layers of data, the road model, the precise lane model, and the localization model, the HD live map supports solutions for automated and driving and vehicle problems like where am I, which way do I go, what's around me, and how should I behave, and how reliable is the data. The typical scenario these days is that there are separate teams for ADAS, for navigation, and for automated driving on our customer side. They work with their partners with the best intentions and focused on their problem domain. And that then results in a situation where software and supporting map data sourced by these teams is also focused on the individual problem domains. The vehicles then get hardware, software, and map data for ADAS. They get hardware, software, and map data for navigation. They get more hardware, software, and map data to support automated driving, and maybe even some additional software and data for features that support electric vehicles and hybrids that support parking or augmented reality use cases. And when that is not orchestrated well, it creates software and map data overlap. It creates the need to transfer more data into the vehicle over the air. It creates the need for more processing power, storage space, and electricity to power all this. It also creates complexity. And it creates a situation where flexibility and reuse gets lost, because the requirements, the sourcing, and the development of solution happen against a specific problem domain and against a brief snapshot in time, often leading to a static outcome. Personally, I believe this is not very resourceful, and I also believe this is not sustainable. A very smart man said the following a very long time ago: it's not the strongest of the species that survive, but the ones that are responsive to change. And you probably heard that one already. And it's a quote that is attributed to Charles Darwin, the scientist and biologist that's known for his theory of evolution. There is a huge wave of change ahead of us in the automotive industry. That change is not only coming from more advanced levels of assistance systems and automated driving. Change is driven by the software that powers these features. Change is the automotive platforms that are becoming even more scalable and flexible when those platforms are electric platforms. And it's software that powers electric vehicle platforms. Change is new players that join and shake up the industry and are coming from the US, from across Europe, from Japan, from Korea, from China, but also from rather unexpected countries like Turkey and Vietnam. If we want to sustain our respective market positions, sustain success and growth rates, let me say it more dramatically, if we want to survive, we cannot sustain. It's not enough to sustain. Sustainability is the capacity to endure in a relatively ongoing way across various domains of life. That's what Wikipedia says about it. And to endure is not going to be enough. We need to evolve. And we need to do so much faster and be responsive to change. Software and data are not a piece of sheet metal. It's not a wear and tear part. You should not define, design, and build software databases or data services 3 years ahead of an SOP and then have to maintain and support that exact code for 5 to 15 years. That is the contrary of evolution, and I believe it will eventually kill those who stick with this way of running their business. We must understand and embrace that software is an organism with the ability to constantly evolve with its environment. There is our chance to evolve with the changing consumer needs, with the market changes, and with the possibilities for a sustainable future. This is complex. So for the sake of simplicity, let me only focus and look at 3 factors here: hardware, software, and data. First, hardware. Updating or changing hardware after a vehicle has rolled off the production line is not easy nor cheap. And you want to achieve economies of scale, right? So I get that. This can most easily be achieved by committing to stick with the hardware parts for the entire production run. But you can and have to be more forward-looking when it comes to specification of hardware. As an example, I often find myself in discussions about storage space and how much of that is needed for map data. I understand you want all the map data, coverage and richness of attribution, but you can only offer limited in-vehicle storage space. So if you want it all, and if you want it all installed in the vehicle offline and you want it updated for 5 to 15 years, then it will need space. But take a step back from the problem and you will see that this is not really about a larger hard drive. The solution is to be smart about what the future will bring. And the future will bring data connectivity in various forms that will become more ubiquitous and less costly. So instead of storage space, consider investing in data connectivity and software. The software needs to be smart and manage how much data and when this data is loaded into a vehicle. Let's talk about the second factor, software. Software is an organism and that needs to be embraced. It's a beautiful thing. I work with many very smart software architects and engineers daily. If only we can unleash them and give them more freedom to define and build software that can evolve over time and that can be updated along with that evolution to make use of new possibilities. of connectivity, of new data types, of running software more efficiently, then we are on the right path to evolve along with the changing environment. It's all about allowing for evolution and change and doing this step by step. Software is key for automated driving, and it's very multifaceted. It's unknown territory. It's far from being mature. There is a tremendous learning curve, and we need to adapt and evolve along that learning curve. What software can do to understand the environment around the vehicle and how to control the vehicle as a result will make quantum leaps in the next few years. In the premium vehicle segment today, you need to offer features on SAE level 2+ at least. But the software and data you spec and build today will be outdated in a year or two. Yes, it's complex, it's expensive, and the evolution from driver assistance to automated driving is not as fast-paced as it was predicted. But let's not underestimate the hungry and the foolish. To keep up with the new players in the industry, we all must be ready to learn and evolve fast. And that means updating software often. It means learning from observations, from tests, from each other. It means taking these learnings and applying them, simulating the changes, and be ready to roll them out to the vehicles that are already on the roads. It means collaborating across companies, because none of the OEMs and none of the system vendors have the market share across all the regions they want to do business in. If you have a good market share in one road region, doesn't mean you do in all the other regions. And that is a challenge on a micro level as well. If you sell well in France, it doesn't mean you do in Sweden and vice versa. If you have lots of sensor data available in Stuttgart, it doesn't mean you do in the rural areas where drivers of luxury cars retreat for their well-earned weekends. But of course, they expect the automated driving features of their cars to work everywhere. We need each other and pool our sensor data and how that is published back to the vehicles. Like for hardware, we need to look at the challenge with an evolutionary perspective. And my perspective is that map software components should be architected and built to support the entire feature stack, not just one problem domain. That allows the components to support each other and scale from basic features like intelligent speed assistance to ADAS, navigation, and automated driving. Map data to support features should be brought into the vehicle by one single map management component that connects to map services with standardized interfaces and then serves up the map data to the various features in the vehicle. And that leads us to the third factor, data. It is data that fuels the software organism. Better data, more data, highly fresh data. It has a direct impact on how well software can run and the results of it. It is data that enables new features in navigation, driver assistance, automated driving, and connected use cases. It's not longer enough to know where the roads are and how to classify and attribute them and then update that every quarter or less often. You want to know what the situation is on the roads when you are about to drive them. You want to know about geometry, rule changes, the traffic situation. You want to know about availability of parking and EV charging spots. You want to give your consumers a seamless experience tied to your brand and not a cluttered one across multiple different brands and devices. And for that, you want the best data everywhere with the highest possible granularity, accuracy, and freshness. And there's only one way to achieve this. It is to make use of the possibilities of software evolution, continuous feedback loops and learning, and industry standards that allow us to process, publish, and then weave together data more easily. And exactly that standardization of automotive map data formats and interfaces is the mission of the NDS Association, and it's over 40 automotive industry members. NDS is the worldwide standard for map data in automotive ecosystems, and with NDS Live, we're defining and building an evolution of that worldwide standard. The motivation and progress to date was presented just before this session. NDS Live is an evolution enabler that allows for more modular and minimized data consumption. And this is so important to enable connected solutions that are smart about consuming and using data when and as needed. As a result, this offers cost advantages, scalability, and a great user experience. And that's what we're building at here, a stack of map content publication layers, consumable via map service APIs. with NDS Live for automotive being one of them. From ISA to automated driving, you consume the layers you need as you need them and add more features over time. And if you have special needs, then there are additional layers you can easily add to the single map data stack that serves all features in the vehicles, redundancy-free, aligned, and referenced to each other. So let me wrap this up. We're coming from a 35-year history of using map data, software, and hardware in consumer vehicles to offer technology that makes it easier to find our way to a destination. Navigation saves fuel and stress and lives, and it has probably saved a few marriages too. The possibilities of technology continue to evolve. Map data is not only powering navigation, but also driver assistance and automated driving. And that evolution is accelerating with the emergence of electric vehicle platforms. We have new industry players that take an approach that accelerates the market dynamic and change even more. If we adapt to this change by making smart hardware choices and embrace connected software as an organism that is fueled by data, we will not only sustain, but continue to win. And with that, I thank you very much for your attention. And I hope I was able to give you some food for thought.
Yeah, thank you very much, Philip. And at the moment, I don't see any questions in Zoom. We're a couple of minutes behind the schedule. I think we'll still be fine to answer some questions. So go ahead if you have. If you don't have or would like to think a little bit more about Philip's thoughts, I would be really curious on behalf of the NDS team to get your feedback if we should leverage the topic of sustainability and environmental aspects more in the NDS activities, also regarding marketing, publications of seminars and white papers, etc. So yeah, please feel free to use the Q&A. Let's see. One question now. So Philip, what do you think about the future of mapping itself? Crowdsourcing versus mobile mapping? Would you like to take this or?
Yeah, sure.
Forward it to someone?
Yeah, so there's a lot of new players, right, that use sensor data and things that are camera observable. But there's also a lot of data that is not detectable by sensors, like road rules that are not signposted, a classification of roads that you just need to know. And that context is important. So one example I often give is when you, let's say you drive out into the countryside and you stop your vehicle on the side of the road, you take a walk, you come back. So the context of where you are and what type of road you are is lost at that moment, right? Unless you somehow persist that in the software. There is attribution of roads that you need to know about. And that's why at here we still believe in taking a lot of data from third party that we source from governments, from various sources where we get information and data that's not sensor observable, and bring that to our map. We have discussions with OEMs around that topic, and we see a trend that, yeah, there is a lot of data that you can observe and use, but there is still a huge need for that unobservable data and the road rules and regulations that you need as part of a map data set.
So the answer is actually both, crowdsourcing, mobile mapping, public authorities, measurement system, so yeah. Good, thanks. So thanks a lot, Philip. And
thank you for watching. Visit our website for news on NDS at nds-association.org.